My name is Alan Ridlehoover. My pronouns are he, him, and I'm a senior engineering manager at Cisco Meraki.
And I'm Fito from Zastrow. I also use the pronouns he, him, and I'm a staff software engineer at Cisco.
So, we call this talk Derailing Our Application, but that's a little bit of a misnomer. We're not actually removing Rails from our app. Rather, we're decoupling our business logic from Rails constructs. Because we found that Rails was both getting in our way and not providing enough structure at our scale. Now, before we dive into that, though, we need to share a couple of concepts so that we can establish some common language. Let's start with a quick lesson in economics about convex and concave payouts. It'll just take a minute. Oops. Back. So, a convex payout is one that only requires a small investment up front and usually results in a small loss. But occasionally results in a very, very large profit. This is venture capital. You make lots of little investments, lots of little experiments, and you see what pays off. Now, a concave payout is one that requires a large investment and usually results in a small, reliable profit, but can often, or can actually, it can result in a very, very large loss. Now, this is basically retirement. You have a nest egg, you want it to grow, but you cannot afford to take a loss. So you plan carefully and invest conservatively. All right, everybody understand convex and concave payouts? Cool. That's the end of our economics lecture. Let's apply this concept to software development. So there's this guy, his name's Kent, you may have heard of him. He has a talk called 3X. In that talk, he shows how the convex and concave payout curves are actually a single curve. Together they form this S-shaped curve that represents the application development lifecycle in 3 phases. The first is exploration, the second is expansion, the third is extraction. Exploration is the convex portion of the curve. The goal here is to find the thing that's going to pay off. So you try lots of little experiments. Expansion is all about growth. You found that thing, it is taking off, and now it's your job to scale it as fast as you can. And then finally, once growth slows and you've accumulated a large customer base whom you cannot afford to lose, the application enters this extraction phase of its life cycle. And here you've reached the concave portion of the curve. Your goal is to eke out as much value as possible without risking any losses. So knowing about this 3X application development lifecycle and where your application fits on that curve can inform the decisions you make. So where is Cisco on this 3X curve? Well, when we started putting together this talk, we thought our monolith was nearing extraction, but it turns out not so much. The data is really pretty clear. We are still expanding. To understand the challenges we're facing and why we are decoupling ourselves from Rails, let's look at how we got to where we are. So in 2006, we were a startup with this crazy idea for a service that no one else was providing, remote network management over the cloud. We set about exploring that space. It was uncharted territory. Rails 1.0 had just shipped in December 2005. Work began on our dashboard, which at the time was Meraki, in April 2006. And at that point, people were still writing fat controllers. No one knew the Rails way. We hadn't yet lived through the Ruby 1.9 upgrade. There were no RESTful routes, you couldn't chain active record queries, and you had to do dependency management yourself because Bundler did not exist yet. We were not well-grounded, eloquent, or practical. But that didn't stop Cisco from acquiring Meraki in December of 2012 because they recognized that we were moving incredibly fast and we had something they didn't. And that's despite the fact that the central concepts in our application were written long before any of those best practices were established. So by today's standards, our code was a mess. But we'd just been acquired. And all of a sudden, we had access to way more customers, and they wanted products and features we didn't have. So our Rails app grew a bunch, despite the mess. So we went basically into that full-on expansion mode where we're trying to keep up. At the end of 2012, there were 38 active contributors to the application and about 250,000 lines of code. 3 years later, in 2016, there were twice as many contributors and over 500,000 lines of code. Then 3 years later, about the time Fito and I joined, the engineering team had doubled again, and there were nearly 1 million lines of Ruby code. 3 years after that, there were over 250 monthly active contributors and more than 1.7 million lines of code. And then, in 2022, Cisco announced that our most powerful Catalyst devices would be manageable via the Meraki dashboard. Now, that meant that we needed to add support for several hundred products to our dashboard, to our Rails app. So in the 3 years since 2022, monthly active contributors more than doubled. We're over 600. And we grew the code base to over 5 million lines of Ruby code. That's up from 4.25 just last July when we gave this presentation at RailsConf. Okay, so during the Explore phase, we built the central concepts of our application without the benefits of modern Rails best practices. And by today's standards, our code was very messy. But at only 250,000 lines of code, it was probably pretty manageable. Early in the expansion phase, we saw significant growth both in our code base and our team due to the constant barrage of new feature requests. That growth in the code base led to some astonishingly large models and controllers that caused complexity to increase, making the code harder to understand, harder to change, and harder to test. And without adequate test coverage, we were unable to move as quickly and confidently as we liked. Furthermore, because the models and controllers were shared across the entire organization, no one individual or team could act to improve the code without either gaining consensus across the entire org or imposing their solution on everybody else. Just here you go. So we wanted to increase our velocity as we continued to scale. And to do so, we felt we needed to look beyond Rails' traditional MVC architecture in order to reduce complexity and increase testability. We also felt like Rails wasn't giving us enough guidance about how to structure our application to support the team at our scale. We needed to change our approach in order to address these issues. Fito, would you like to explain what we're doing?
Let's do it. Can you all hear me okay? Yeah. All right. So, like Alan was saying, we wanted to reduce complexity and we wanted to increase testability. Now, we chose to modularize our code base in order to address those concerns. We also wanted to improve autonomy and accountability. And we decided to start to add boundaries within our monolith to support these qualities. Now, I'm going to show you how we're applying these concepts to our Rails monolith. The first thing we did was we taught people how to remove the business logic out of our controllers. That, you know, in a big sense, like modularization is just breaking big things into smaller things. So we broke our large controller actions into much smaller objects. And we decided to start there for a couple of reasons. First, our business logic is the most valuable code we have. It's really what differentiates us from our competitors. It's also where developers spend most of their time adding features and fixing bugs. So this is where we get the biggest return on investment from increasing test coverage and lowering complexity. And second, Rails controllers can be really difficult to test. They often require complex setups in order to exercise every code path. And the more logic you have in your controller, the more cumbersome testing becomes, and eventually people just stop writing tests. It becomes a burden on development. And so they opt instead for manual testing or high-level end-to-end testing. So we restructured our code to make it easier to test via simpler, quicker unit tests that require less setup. So I'm going to show you an example. The code in these examples is made up, but it was inspired by real production code. There might have been some AI involved in changing the concepts, but the shape of the code is from real production code. And so instead of networking concepts, though, we're going to use concepts related to coffee machines. So this is a controller. that handles requests to update settings of multiple coffee machines that belong to a cafe. It's pretty long, so don't feel like you need to understand the code that's on the screen. Instead, I want you to focus on the shape of the code and the variety of colors that you see on the screen. Both of these are indicators that there's lots of different things going on in this controller. But I'm going to walk you through some high-level things that are happening. So the first one is that there's an active record transaction, and this contains a loop. So now this is looping over an array of arrays containing a coffee maker ID and the corresponding changes that you want to make to that machine's configuration. Now, inside the loop is where most of the business logic lives. The code is doing things like validating input, populating errors, is serializing a hash of changes, and then finally, it saves the settings. And then outside the loop, we have a little bit more business logic. The controller is creating this cafe event, which is probably consumed by some other part of the system, potentially a notification system of some sort. And then finally, there is some aggressive exception handling and an ensure block that is in charge of rendering a response. It's like, we don't know what went wrong, but we gotta render something, right? There's a lot going on here, but we don't have to solve all of that at once. In fact, our approach has been to first focus on the body of the loop. Now, before I show you what that looks like, this is a caveat that I usually give when I present on code like this. We wouldn't be refactoring any of this code without ensuring that there are at least some high-level tests. So we're going to assume we have enough coverage to tell us that if we completely break the method. So with those tests in place, let's go ahead and start extracting code. So here, we've extracted a class called update water tank settings. This class encapsulates the procedure inside the loop and is now only concerned with a single coffee maker. Now, this makes testing the logic much easier since you no longer have to think about HTTP. The controller is not involved here anymore. You also don't have to think about the loop. You can focus on the effects this class has on the settings of a single coffee machine. But there's still a lot of logic left in the controller. So the next step is to extract the remaining business logic out into another class. Here we created a new class called update coffee machine settings and move the rest of the business logic there. So now our controller looks a whole lot more like a scaffolded Rails controller, and it's only responsible for handling the HTTP request and sending the response. It is collaborating though with a new class to build the response. Now, the new class, on the other hand, still has several responsibilities. Still not great code to work with, but we're going to defer that work for the next person that touches this file. Because our goal here was just to get it to a point where it was easier to test, especially our business logic. And so now that it's out of the controller, we've accomplished that goal. We can write unit tests for this, and we can move on for now. So extracting business logic out of our controller helps us achieve this simplicity and testability. But extractions alone are not enough to promote, autonomy and accountability. You can still extract this code and throw it in some generic place that nobody owns. So to address these concerns, we need some semblance of walls within our code base. Now, these boundaries will help reduce the cognitive load across the entire engineering organization. Think about it. An engineer now no longer needs to think about all 5 million lines of code if they have an area that they can focus on. They can just focus on this code that their team owns. And they're free to improve it without having to get organizational consensus before making changes there. Now, we start with all the code in the controllers directory. All the code was in a controller. But now that we've extracted classes, we have the ability to move that code into a different directory. So here we've introduced a domain directory. It could be called something else. In this case, let's call it domain. And we created a coffee machine subdirectory. And we moved the new classes in there. Now, this directory structure provides a namespace where we can put all the business logic that's related to coffee machines. It also allowed the team in charge of coffee machine features to take ownership. Now they can experiment with different approaches without requiring that consensus I mentioned from the entire organization. And they're also accountable for the level of test coverage and if there's any test flakiness in their area. Plus, with the coffee machine namespace in place, now we can rename the classes and leverage the information that's already provided by the namespace. All right. The next thing we did was to teach people to remove their business logic from our views, specifically ERB files. Now, views present a different challenge. ERB files are not well supported by community standard code quality tools like Flog and SimpleCov. There's been some improvements in that area, but it's still not great. And also, view tests are difficult to write and can produce false positives because you have to set the instance variables that the view is going to use in your tests, and these are typically set up by the controller, so you end up with a situation where you can change the code in the controller and continue to have passing tests for your view. It's just possible to have broken code and passing tests. We've seen that. Plus, the embedded Ruby syntax makes it harder to understand your business logic. It's harder to read than plain Ruby. It's mixing, presentation with business logic. So we restructured our views to make the code easier to test and easier to understand. And as a bonus, we can also now measure the complexity and the test coverage for this logic. So let's take a look at an example. So here on the left side, we have a controller that's in charge of rendering configuration properties for a coffee machine. Now, the controller itself is not doing much. It's just finding a coffee machine, and then it's setting a few instance variables. And then it renders the template. Typical Rails magic, right? Now, on the right, we have the view, or the ERB template, and this template contains the business logic that decides which properties get rendered under what conditions. Now, the output is a text file. It just has key value pairs that are separated by a new line character. It's just a plain text response with a list of key value pairs. Now, in this particular case, we looked at this response and we determined that we don't really need ERB for this. A plain old Ruby object or a poro should be enough. And so I'll show you what we did with this, but again, I recommend that you have at least a test covering large parts of this. And assuming we have that, here's what we did. So we have the controller and the ERB template as we left them a moment ago. We're going to replace the view with a poro. So here we created a new class that's called coffee machine configuration. Now this class encapsulates the business logic in charge of building the configuration properties. We've also pulled the code that calculated the instance variables in the controller into this new class. Now, we did that because the instance variables were deeply embedded in the view's logic. The view really cared about them. The controller had no use for them other than setting them up so that the view can then access them. However, we left the code that finds the coffee machine in there because the controller does use that logic to determine what the correct HTTP response should be. The new class, on the other hand, does not even need to be instantiated if there's no coffee machine found. Now, the benefits of this extraction are that the coffee machine configuration class is now easier to test than setting up a test for an ERB view. We can also get coverage and complexity information on the new class very easily. And the controller is much easier to test since it's responsible for less business logic. You just need to test the found the thing or didn't find the thing case. And then all the other tests can move to the coffee machine configuration class. All right, let's look at where this code should go. So we start with code in controllers and views, and then we replace the view with a pure Ruby object. So we can put this new coffee machine configuration class in the domain coffee machine directory and rename it to just configuration since it's now in the coffee machine namespace. All right, and the next thing we did was to move business logic out of our models. Now, this is where you might think this is unnecessary or maybe even counterintuitive because isn't that what the models are about? Skinny controllers and fat models is considered a best practice in the Rails community. However, we have a few reasons to move our business logic out of models. Most of our models represent these core concepts in our application. And so that makes them magnets for code. The more code gets added to these models, the lower the cohesion, and the higher the chance that methods will be implicitly coupled with each other. So these models tend to become junk drawers, making it hard to draw boundaries and for anyone to take ownership or responsibility for them. So once again, we restructure our code here to make it easier to test and to draw those boundaries. Let's take a look. All right, on the left, we have a controller action that's just in charge of broadcasting details about a coffee machine. It looks very simple. It just queries the database to find the right coffee machine, and then it calls the broadcast details method on the coffee machine model. Now, on the right, we have the coffee machine model. The broadcast details method checks various attributes on the model itself and then builds a string that contains the machine name, recent activity, and the supply status. Now, once again, make sure you have tests before you do this. And assuming we have that, we here extracted the logic from the broadcast details method into a new class called coffee machine broadcast details. Now the class receives a coffee machine now and performs the same logic to build that string that contains the machine name, the recent activity, the supply status, but the new class has a few advantages over having this as a method in the model. First, it is no longer implicitly coupled to the model attributes anymore. It makes it more extensible. As long as it receives an object that responds to the same methods, it can be used in other contexts. You can even pass an immutable data object if you want. Second, it's easier to test since the coffee machine object that's passed in the initializer can be more easily stopped if you need to. And finally, the code in the class is no longer accessible to other methods in the model. This is a real problem in a gigantic code base. There's a lot of incidental coupling via referencing other methods or instance variables in the model, and so this prevents that. So we started with code in a controller and a model. We then extracted a class out of the model. And so we can put the new coffee machine broadcast details class in the domain coffee machine directory and rename it to just broadcast details. All right. So that was a brief look at some examples of how we're extracting our code out of Rails concepts or Rails constructs. But you probably already figured this out. Let me summarize the approach. We are putting our business logic in plain Ruby objects. That's it. But we're also moving these objects into namespaces to start to create these boundaries around domain concepts. So if we bring together all the classes we extracted here, the directory structure will look like this. Now, you may have noticed that these classes are not organized by framework concept or by pattern, which is something you're probably used to when you use Rails. Update settings and update water tank settings, I guess you could consider them service objects. Well, if you look at broadcast details in the configuration class, those are kind of like serializers, right? We have explicitly decided not to be prescriptive about how the code should be organized inside these domain directories. And the reason for that is we want to allow teams to decide what works best for them. So sometimes teams will organize their code by subdomains. Like, for example, you might create a water tank subdirectory there. Other teams, though, really like organizing their code by pattern. So, for example, you might create a services and a serializers directory and move some of the code there. They have now the autonomy to do that, though. All right, we're just about done. Alan, you want to close us out?
Yeah. Thank you, Fito. All right, so we wanted you to take a few ideas away from this talk. I'm going to cover them, and I'm going to show you sort of what kind of success we've had with this approach. So, first concept is the convex and concave payouts, two different investment models that can be combined into a single curve to model an application's development lifecycle with the 3 phases: explore, expand, and extract. Understanding where you are on that chart can actually help you make informed decisions about the investments you're making in your application. And understanding the route that your application took to get where it is today not only builds empathy with the developers who built what you have today, but it helps you think about and prepare for the app you want to have tomorrow. And finally, we wanted to share our experience. And due to how old our app is and due to the growth trajectory we've been on, we found Rails was both kind of getting in our way and not providing enough structure or boundaries inside the app. Rails and the lack of best practices led us to super large models and controllers with business logic everywhere, even in our views, making our business logic hard to separate and test in isolation. Historically, this has caused us to struggle with complexity and with testing. Modularizing our code allowed us to work on smaller, more testable things. And because we've historically had business logic from different domains mixed together inside the central concepts of our app, both controllers and models, it's historically been difficult to make improvements. We either needed to obtain consensus or one team would need to force their improvements on everyone else. Adding those boundaries between domains has given teams the autonomy to make improvements to their own code, as well as accountability for their code. We're seeing massive increases in test coverage. In 2019, when Fito and I joined, I measured where our coverage was. We were at 46% for an application that at that time was over 1 million lines of code. 3 years later, in 2022, with a bunch of nagging and a bunch of pushing, we had managed to bump that number to 55%. In 3 years, we went 9%. Again, the codebase was growing during this period. At that point, we began the extraction process. We started putting code into this domain folder. And now, over half of our code, half of that 5 million line code base is in that folder. It's extracted into domain folders inside that domain folder. Test coverage for that folder, because people now own it and they're accountable for it when it fails, is 97%. So 9% growth before the modularization project, 42% in the same 3-year period since then. We're also seeing corresponding decreases in complexity. The average method complexity in our modularized code is 30% lower than the rest of the application. When you extract smaller things out of larger things, those extracted bits are going to be less complex, and they're easier to test. We've also seen big improvements in things like flaky tests and Sev1 responses, since it's now easy to tell which team owns the bit of code at the center of the problem. Now, probably the hardest thing has been autonomy. Giving teams autonomy within their domains means that they might not leverage the techniques we've described here. It's up to them. And in some cases, teams have used their autonomy in ways that have caused issues outside their domains. This is a Ruby app. Everything's like in the global space, so they can pollute it. This discussion around how far the autonomy extends can be challenging. Now, most teams are still at the extraction phase of our process. Others have moved far enough along to wrap up APIs around their code in their domain folder and extract services. Now, we expect that as other teams get more mature and have more of their code extracted, they may look at doing something similar. That's it. It's all the time we have. But if you're interested to know more about our journey, you can reach out to us here, or you can come network with us over at the booth. And that's it. Thank you so much.